Hello. Now let us solve a problem on maximum in-plane shear stress. Now the problem is on your screen. Now in this problem we have a point given and these are the stresses, okay? And we have to find the maximum in-plane shear stress, and we also have to find the associated normal stress, okay? So basically what we have to find, we have to find tau max in plane, and we also have to find the normal stress, okay, sigma n, or we also denote it with sigma average, okay, on the plane where we have the maximum shear stress, okay, because we already found in our previous class that on a maximum shear stress plane, the plane where maximum shear stress exists, there also exists a normal stress, right? So let us find those. Now first of all, we can find the first of all we need to find the plane where the shear stress, maximum shear stress exists, okay? So to find the location of the plane, we will use the formula that we found from the previous class. We will use tan 2 times of theta s. As for theta s is the plane where we have the maximum in plane shear stress, and we know its formula is negative sigma x minus sigma y divided by 2 whole divided by tau xy, okay? Now let us find the value of sigma x, sigma y and tau xy, and then we will be able to find the location of the maximum shear stress plane, okay? So now in this positive side, okay, in the positive side, let us say this is x axis, positive x axis, and let us say this is positive y axis, okay? So based on this, we will use this sign convention for this all the stresses that exist on this plane and this plane, okay? So based on this, what we got, sigma x is, it is this is the sigma x, but it is opposite, right? So it is negative 20 is the magnitude, 20 megapascal, right? Similarly sigma y, we have the same direction, right? So it is positive, so sigma y is 90 megapascal, right? Now tau xy, now we can find the sign of tau xy based on either this one or this one, okay? Now if we consider this one, you will see it is in the same direction of this, right? And if we consider this one, okay, we can consider any of these two, again it is in the same direction as that of this axis, okay? So tau xy is again positive because it is in the same direction as that of this coordinate system, okay? So tau xy is what is the magnitude? Magnitude is 60 megapascal, right? So it is 60, okay? Now based on this, we will be able to find the tan 2 theta s, right? So it is negative. Now sigma x is what? Minus 20 minus sigma y is what? 90 divided by 2 whole divided by tau xy, which is 60, right? So let me use a calculator to find the value. Tan 2x, I will denote the theta with x, it is equal to negative sigma x minus sigma y by 2 minus 20 minus 90 divided by 2 whole divided by 60. So we got two values of theta s, okay? So based on this, from this what we got theta s is equal to 21.25 degrees, and we also got theta s to be 111.25 degrees, okay? So this equation gave us two angles, okay? So what does it mean? as we already know, because we know whenever there is a maximum shear stress plane, there exists another plane perpendicular to it, okay, and the magnitude of this shear stress on the another plane is the same magnitude but opposite, right? So we got two, these are the locations of the maximum shear stress planes, okay. Now we only need to find the magnitude of maximum shear stress on this angle, because we know on the other angle it is just the opposite, right? So the same value but minus, right? So let us see. Now to find the maximum shear stress in plane, okay, we can either use the the formula that we found before, okay. It is this whole divided by 2, right, plus tau xy whole square, okay. But the problem same is the problem in the principal stress formula, and same is the problem with the tau max in plane formula. The problem is if we use this, then we will get the maximum in plane shear stress, but we don't know which stress exists on which one, right? So what we are going to do, we will not use this formula, okay. We will use the the basic formula of the shear stress on an oblique plane, okay. And we will use this angle, okay. So let me erase this formula first, okay. Now by the way, if you are having a pen and paper, you can also practice with me, because these are the answers, final answers are here, okay. And you can also grab your pen and paper and try with me and compare the answers, okay, as we have here, okay. So I will use this formula, tau x prime y prime, it is equal to negative sigma x minus sigma y divided by 2. Then we have sine of 2 theta plus tau xy cosine, right, cosine of 2 theta, okay. Now add theta s equals 21.25 degrees, okay. So I will first put this angle in this, okay. So this is going to be theta s, right, instead of theta. So because we use the angle theta s, it means we are finding the shear stress where we are finding the shear stress at theta s, and theta s is the location of maximum shear stress plane, and it means this thing is going to be what, tau max in plane, right? So at theta s, so let me just put this thing in the formula, okay. So I will just use the calculator. It is negative sigma x minus sigma y by 2. Now we know sigma x, sigma y and tau xy. I will use these values directly in the calculator. It is minus 20 minus 90 divided by 2 times sine of 2 times theta s, and I will use the theta s of 21.25 degrees, 21.25, okay. Then we have plus tau xy is 60 times cosine of 2 times the angle is 21.25, okay. So we got 81.4, okay. So from this we got the value of tau max, which is in plane, okay. In plane tau max is 81.4, and the unit is what? Unit is megapascal, is everywhere, okay. So it is also going to be megapascal, right? So we know at this angle we got this, okay. So it means at theta s equals, what is the another theta s? It is this 111.25 degrees. What is going to be the tau max? Because from the property of max shear stress, we know if we found something shear stress at one angle, it means at the other shear stress angle, maximum shear stress angle, the magnitude is going to be same but opposite, okay. So at this theta s, we don't have to put it here, okay, because we already know it is going to be the same but opposite, okay. So negative 81.4 megapascal, okay. Now we know which stress belongs to which maximum shear stress plane. Okay, so if we had used the previous formula, we wouldn't know these details that this maximum stress exists at this. Okay, now let's compare our answer. As you can see, theta s1, okay, because by the way we call it as, theta s1 and theta s2, okay, because we have two, angles, so 1 and 2, so 21.25, okay, so it is 21.3, basically it is rounded off. Okay, so we got this correct. Then we have 111.25, again in the answer it is rounded off, so don't worry, it's also correct. Now tau max we got 81.4 and negative 81.4. Okay, so plus 81.4 and minus 81.4. Okay, so we have done everything correctly. Now sigma average, it is very easy to find. Okay, now from the previous class we know the normal stress on this plane, it is equal to sigma x plus sigma y whole divided by 2. Okay, so let me just put the values. Now sigma x is minus 20 and sigma y is 90, so it is minus 20 plus 90 divided by 2. So I got 35 and it is megapascal, right? Because everything is in, every stress is in megapascal. Okay, so we also got the sigma average. Okay, now what is more important right here is to sketch. Okay, to sketch this, shear stress plane. Okay, so let us sketch it. So I will use this plane. Now let me change the color first. Now let us say this is, this is xy plane. Okay, now I will draw the shear stress planes. Okay, shear stress planes. Now shear stress planes are 21.25 degrees and 111.25. Okay, so let us look at this one. So it is positive. Okay, so positive in the plane stress transformation, we know a positive angle of inclination means an anti-clockwise angle. Okay, so I will rotate this by, I will rotate it in anti-clockwise order. Okay, so this thing is, this is 21.25 degrees. Okay, so it automatically means, okay, this one, this plane, it is already also going to be 111.25 degrees. Okay, now what is the angle between them? It is 90 degrees. Okay, it is 90 degrees, because I have told you, if we have one shear plane, okay, maximum shear plane, then we will have another maximum shear plane at an angle of 90 degrees. Okay, so it means this is 90 degree. And by the way, you can also verify this 90 degree. Okay, you don't have to verify, but I will, verify for, for your understanding. Okay, only one time. Okay, so this angle we will find it from this whole angle minus this angle, and it should be 90 degrees. Okay, so if I, 111.25 degrees minus 21.25 degrees. Okay, so it should be 90 degrees. So let me use a calculator. It is 111.25 minus 21.25. You can see I got exactly 90 degrees as answer as expected. Okay, so it is always 90 degrees. Okay, so let me erase this. So it was just a verification for your understanding. Okay, now we will draw the, body or the planes. Okay, so let us draw the planes, not this. Let us draw the planes. Now you can see these are our planes. Okay, and on this we have a normal stress which is positive. Okay, so if we consider this as, this as positive x-axis, because this initially this was x. Okay, so I will also explain it here. Okay, now because we rotated x and this is x prime. Okay, why it is x prime? Because we rotated this and we got this, and then we rotated this, it is y prime. Okay, now the sigma average is 35. Okay, so it is everywhere on the planes. Okay, so let me use a thicker pen. Yes, So it is positive, it means it is towards this, right? Because positive means towards the, the same sign as the coordinate axis, okay? So it is like this here, and also this here, and the value is 35 megapascal, okay? 35 megapascal. Now if you wish, you can draw the, the supplementary too, okay? So this one is the supplementary of this is 35, and this one is 35, okay? Now let us draw the, shear stresses. Now shear stress at this angle 21.25, this plane, right? It is 30, where is it? It is 81.4. It means it is positive, right? And if we look at this plane or this plane, the positive means, towards these, right? So the positive means like this, right? Why it is positive? Because it is in the same direction, right, as this, okay? Or we can also draw it here, right? This is also positive. Why it is positive? Because it is in the same direction as that of its own coordinate system, okay? So keep in mind, I compare it with this x prime and not x, because x was the old, right? And these are the new ones, transformed, right? Transformed ones. So we compare it with that, okay? Now these are what? 81.4 megapascal, okay? Basically everything is a megapascal, right? Megapascal. And now if you wish, you can also draw the complementary parts, okay? Like this and like this, okay? Now why I draw them like this? Because in the complementary, because we have a positive shear stress, and on this side, this is the dark side, right? And this thing is the positive side or the bright side, okay? Now in the dark side, the that thing is positive, which is opposite, okay? So it is opposite, this one is opposite to this, right? This is opposite to this, okay? Because this is in the dark side, so it is positive. Similarly, this one, this thing is opposite to this, so it is positive, okay? So that's why I draw them in the opposite direction, okay? So again, this is 35 mega, not 31, sorry, it is what? It is 81.4, right? 81.4 megapascal, and these are 35 megapascals, and this is normal stress, right? Average stress. So here we have the, sketch of the plane of maximum in plane shear stress ready, okay? So I hope you understand. If you have any doubts, you can comment, or you can also contact me, okay? Now before I, finish this lecture, let me show you my, the homework problem. So here you have, this is your homework problem, okay? So in this problem, you basically have a rod and it is under torsion, right? And if you take this small, this, element, and the, because of this torsion, okay, this we are having this tau shear stress acting on, everywhere, okay? And you can see there are no normal stresses, and what you have to do, you have to determine a the maximum in plane shear stress, and also the average normal stresses on each plane where maximum, in plane shear stress exists, okay? So this, and also you have to find the principal stresses, okay? So this is your problem, and these are the answers, okay? So you can try using your pen and paper, okay? And the next lecture will be the solution of this homework, okay? So thank you for watching, and see you soon.